My name's Dave Lewis. I am the resident Canadian here to give a presentation, and it's not a presentation about big data per se. It's about the security that goes around it. And one of the things is, you know, when I was having fun with the name about getting Hadooped, originally it was please don't pee in my data lake, and my boss said, yeah, we probably don't want to go with that title. And I was like, all right, cool. So over the years, I have had the benefit of protecting enterprises in all manner of shape and size. I've done financial institutions. There's plenty of seats up here, sir. Financial institutions, governments, militaries, high-tech companies, all sorts of things like that. And along the way, it's been really an experience to see how people handle their data, how people try to, you know, protect their data, or in many cases don't. And that's where people like me come into place. So I myself, I am a hacker by trade. But the funny thing is, if you start searching the internet looking for things about hackers, it says hackers must die, hackers must be stopped, all hackers must die. People generally don't like hackers a whole lot. But we do serve a very real purpose. We are here to help secure the enterprise, secure the data, to make sure that we are be able to do what we need to do in a safe and secure manner. So what is the big idea here? The idea that I'm going to be talking about today is a concept called zero trust. And this is a concept that was a term coined back in 2010, and I'll talk about that a little bit more in a bit. The whole idea here is about limiting access to resources, limiting access to data to only the folks, only the applications, only the APIs that need to actually touch the data itself. And it's about reducing risk in your environment. So typically what have been dealt with as what is the perimeter over the years is the idea of we have a castle wall and a moat and everything is fine. But the reality is, as we go through time, is that once people were able to traverse that, once the attackers were able to get in, they were able to gain access to that data, and then in many cases it was all over but the crying. A lot of reports that we read today, we'll find out that the average mean time between a data breach and somebody discovering it is roughly about 200 days. So if you just sit there and think for a second how much damage can be done in a day, let alone 200 days, if an attacker is able to gain access to your data. And we really look at this as we go through, and we see all these different enterprises over the years that have had the castle wall mentality, and we've even seen this with Google, with Target, where attackers were able to breach their exterior, and once they were in, it was basically a fait accompli. The attacker was able to get away with whatever they wanted to. I've worked in an organization that suffered a data breach as well, years ago. It was not a pleasant experience in any way, shape, or form, but it was because we missed something, something that was simple, something that we could have fixed, and to be honest, we thought had been fixed, but we had not closed that loop. And that's the problem, is that because they have that time between when an attack happens and when you notice it, it is really indistinguishable in many cases from legitimate traffic. And this is why we have to make sure that we are having an approach that is limiting access to only resources that we know, the people, the devices, the applications, so that we have a strict control over these sort of things. There are all sorts of ways to get through the perimeter as it is today. We have VPN, email, RDP, which is remote desktop protocol. I don't know why people still expose these to the internet when there are rampant vulnerabilities that are going around today, which I'll talk about a little bit more in a bit. And DNS, and of course, HTTPS. This is a huge hole through the wall into your environment. And the attackers know this, and they do leverage this. I've used this myself in one organization where everybody said, oh, it's okay, we're safe, we have a proxy. I was able to actually tunnel through the proxy and open up chat windows, open up, like you name it, I was able to do it. I documented everything, handed it to the CIO, and the CIO went, okay, so we're going to fix all of this. The reason is over years we have learned lessons. Or sorry, lessons have been presented to us, and we haven't always learned from them. So before I ever got into security, which was over 25 years ago now, I hate that I can say that, but I was actually a student of archaeology. And one of the things that I learned during my lessons was about the sack of Rome in 410 AD. Why do I bring this up? Because they were relying on a perimeter-based model. The Visigoths came to town, they set up shop around the city, cut off all access into and out of the city, and eventually the Romans ran out of all their supplies. They were able to use their own security paradigm against them. So back in 410 AD, this sort of security approach was shown to be demonstrably broken. The idea that we have in our minds of what a perimeter is fundamentally flawed. We have to look at it as anywhere an access decision is being made. Be it to the data, be it to the email, be it to whatever the resource is, that is where your perimeter is today. And the thing is, our assets aren't all behind a wall. We have traversed to the point now we have all sorts of resources and all sorts of cloud implementations, be it AWS, Azure, Google, whatever it happens to be. And we want to make sure that when we're working in either a coffee shop or in an office, we want to make sure that we're able to replicate the same working environment and the same level of security. And that is very much possible. So we look at things like VPNs, virtual private networks, for those of you who are not aware of. This allows remote access for workers traditionally to gain access into an environment. And then it would allow them to be able to surf the internet out again. So that was an interesting little bit of a loop there, especially when you realize that the attackers could ride back into the environment. So while it gave you secure access into the environment, it did nothing to protect leaving that environment again. It was really an interesting bit of a wrinkle there. So we want to make sure that we're doing a better job of this and be able to marshal what we have access to. Network access control was another one that came along about stopping bad actors from plugging into devices in the building. But it didn't stop, again, attackers being able to go after cloud-based resources. So this is one of those things where what had been conceptually a good idea, the attackers are constantly looking for ways to break it. And the thing is, we need to look at how we address the risk. When we're dealing with big data or just data in general, we have to make sure that we are doing our utmost to protect that, because that's become the crown jewels. Back in 2017, The Economist put out an article about how data is now the new oil. I thought that was a bit of an interesting little bit of a spin, but it's not all that far from incorrect, or not. Let's try that again. Not incorrect. So as I mentioned, back in 2010, we had the term zero trust was coined by John Kindervag, who was an analyst at Forrester. But before that, in 2003, there was a group called the Jericho Forum who came out with a document on deperimeterization. The whole principle here was basically the forerunner to what became zero trust, about reducing people's ability to access things unless they absolutely had to or were defined as being able to. This was really interesting because back in 2003, I was ropely about the same time I was working for a power company, and I had proposed the idea of hardening all the laptops and laptops, desktops, servers, making them all exposed to the internet. I escaped that meeting with my life because the people who would have had to support it were in that room as well, and they didn't like that idea very much. But here we are in 2019, and this is pretty much standard fare now for a lot of major corporations. Then we jump forward to 2014, and we talk about Google's implementation of zero trust, which they call BeyondCorp. Now, the really interesting thing here is it took them 7 years to roll this out. So when I have this conversation with folks, zero trust is not something where you go check, you're done. It is something to aspire to make sure that you are doing all the core fundamentals that we should have been doing as security practitioners 20, 30 years ago, and making sure that that access is strictly controlled. So what does zero trust really mean? And again, I'll go back to what I said earlier. It's about reducing risk. Because if I go around this room and I ask everyone here what is love, I guarantee you I'm going to get a different answer from every single one of you. And unfortunately, with zero trust, with so many different vendors out there trying to talk about it, it has unfortunately become muddied. I was actually at a conference last year where I asked one company, I said, well, what's your zero trust play? And they said, well, our color is green now for our logo. And I went, are you being serious right now? And they really didn't have anything that they could say as to why their product was any sort of zero trust play whatsoever. They just thought that if they mimicked the logo, which used to be my company, Duo Security, which is now part of Cisco Systems, they thought that would make it zero trust. That doesn't make it. That doesn't do it. The real principle here is that everything is on fire. And when we approach it from this perspective, we really do have a really good level set, because we understand that from this point forward, we can only improve. Because unfortunately, security practitioners feel like this on a consistent basis because we are working so hard to make sure that we are securing all of that data. The idea of the perimeter-based approach was, it's okay, we have a firewall. That is a deprecated notion. That is something that we've been able to demonstrably prove is a broken notion. Now, we take that and then we switch to talking about access control. My friend Karen Elzari, who gave a talk last year, she was talking about being environmentally friendly. Everybody likes to be environmentally friendly, but please don't do it with your passwords. Password reuse is a horrible, horrible idea. Passwords were a point-in-time fix for a reactionary measure. They were not ever meant to be a long-term security play. And I'll talk about that a little bit more in a bit. Pardon me. London Air is not agreeing with me today. So, I'm really hoping I get a lot of hands when I ask this question, but how many people here are familiar with AWS S3 buckets? Okay, that makes me happy. I did that at another conference. It was a DevOps conference. I had 2 hands go up, and I almost fell out of my chair. The idea here with data breaches is that it seems to be happening far too often. And when we're talking about something like AWS, they have a thing there called S3 buckets, which you can spin up with a credit card in a browser, and you can put it as a data repository for image files, graphic, whatever. Like, doesn't matter what you want to put up there. By default, it is set to do not make this publicly available. By default. I even wrote an article for Forbes where I went through and I did screen captures of all the screens so that people could see that by default, because there was this nonsense going around on social media that it was all Amazon's fault for all these data breaches. But the problem is the people that were spinning these up didn't have an understanding as to what the security implications were. And that's no fault of their own. That was the fault of the security practitioners, because we hadn't taken the time to work with folks so that they could understand what would happen if they did bad things. So there are all sorts of reports out there, like for the Verizon DBIR report and the IDC research. One here says 81% of data breaches involve stolen credentials or weak credentials, and the other one is 70% of compromised devices lead to data breaches. Now this is really amazing, because this shouldn't be that hard. And again, we're going back to static passwords and devices being a problem. So let's let you grab that. Cool. This here is from a site called informationisbeautiful.net. They do data visualizations for data breaches as one of the many things that they do. And I enjoy doing this because this one here is from about 2.5 to 3 years ago. Now, if I jump to just a year ago, these data breaches are not getting better anytime soon. Now, Information is Beautiful had to actually go and change the way they were doing data representation simply because it wouldn't fit on the screen anymore. This is something that we all have to work together to make sure that we are doing a better job of securing our environment. Security folks have to do their job, but those of you who are not security folks have to have the ability to stand up and say, what are you doing to make sure our data is secure? What are you doing to make sure our enterprise is secure? Unfortunately, history being what it is, this used to be the security person you had to deal with. I always refer to this bloke as the flaming sword of justice. And the reason I bring that up is because I actually worked with a guy who I called that back in about 2004. His answer to everything was they should be fired. And if he got away, if he had any modicum of power, then a lot of people would have been out of work and there would have been nobody left. But this is not a solution to the problem. Security has to do a better job of enabling you to get your job done. And we look at talking about accessing, we talk about the club bouncer versus the bartender. Each of them is going to ask you for your ID. You should be able to do it in such a way that you can enter your information and then it is traversed from all the different locations that you are allowed to access. Static username and password will not allow that to happen. Something like multi-factor authentication is something that will. It shouldn't matter where you are. It shouldn't matter what application you're using. You should always get the same checks. Now, like I mentioned earlier, when you are in a coffee shop or you're in an office, you should have the same security experience in both of those environments. Because these days, that's the way people work. I have not worked in a physical office now for over 15 years. I'm rather happy about that. You know, commuting to work in my fuzzy slippers is always fun. And it is possible to do this. When we look at Google's BeyondQual model is one example. That was their zero trust implementation. Or we jump forward to Intel's model, which we called Beyond the Edge. And I'll actually go back so you can grab that picture. I see you saw a couple cameras go up. So, oh, sorry. There you go. Always want to make sure I'm not plowing through. All right, and Intel's version. So why is this awesome? because it is dealing with the workloads, the workforce, and the workplace, making sure that all the different elements are secure and not looking at it as, it's okay, we have a gate, we have a castle wall, we're good. That doesn't work anymore. And this is awesome when you look at it as when we're talking about multi-factor authentication as a simple example, because I always refer to that as the gateway drug to getting into zero trust, because it really reduces the attacker's ability to cause trouble in your environment. So if they breach a site and they're able to get usernames and passwords, one of the things that attackers like to do is take those and reuse them against other sites to see what other access they can get. If you're using multi-factor authentication, they can get the username, they can get the password, but they can't get the second factor. And if you have devices that are defined in your asset inventory, then all of a sudden they can't get away with what they're trying to get away with. So what could have been an absolutely terrible data breach suddenly becomes more of an annoyance and a reputational risk item should it hit the media. You want your user to authenticate with more than a static username and password. If you have your house key with your name on it or your house or anything identifying on it and you drop it on the street and somebody picks it up, they can gain access to your house. It's that simple. It doesn't mean that they're supposed to be there, but they can get in. Passwords are very much the same animal. If a data breach happens at a site where they get the username and password, they can then use that on other sites if you are reusing credentials. This is an unfortunate thing. You want to be able to check the hygiene of the devices that you're dealing with. You want to make sure that they are devices that you trust. If you have an environment where you're saying only corporate assets, you want to be able to define that. Zero trust is a way to get there. And you want to make sure that all of these pieces come together in a way that makes sense. So you don't have some nitwit from Canada kind of trying to break into your network, accessing your email. You want to make sure that it's only your employees that are doing so. So the jobs that need to happen in order to get this done. You want to make sure that you have a defined asset inventory in your environment. Whatever that is. If you allow BYOD, that's great. That's fine. You just want to make sure that you're defining what is the risk to your environment. What is it you're trying to secure? How are you limiting that access? You want to make sure that users in your environment are the ones that are supposed to be there. I worked in one organization back in about 2008 where we did a complete inventory of the users in our environment. Of those users that we found, there was about 10 different accounts that had super user level access. Of those 10 users, 5 of them were no longer with the company, and 1 of them had actually passed away 2 years earlier. Within the last year, his access had been leveraged. Someone had actually utilized his credentials in order to access systems, which was really interesting. We now had a ghost trying to access systems. So you want to make sure that that is not a possibility in your environment. And the applications that you're using, from email to whatever it happens to be, you want to make sure that you're marshaling access in a way that only your users can gain access to the devices they need. And there's this very simple steps that you can go through in order to get to a zero trust maturity model. First, establishing the user trust, going through and doing that asset inventory, looking at who are the users in your environment, service accounts as well. You want to make sure that these are the credentials that are supposed to be there. Then as you get that established, you move forward and looking at the visibility into the devices and the activity as what they're doing. So you want to make sure that these users are not trying to surf to sites that they're not supposed to, downloading malicious software and what have you. mercy. And then you want to ensure the trustworthiness of those devices. You want to make sure that those devices are patched to current or N-1. Because if they're not, they can introduce opportunities for attackers to get into the environment. Enforce adaptive policies. If you have developers that gain access to one thing, you want to make sure that they are not actually gaining access to financial systems and other things as well. Right through to getting to zero trust, where you have then limited the access to a point where you can safely say that you are in a better security posture. And we look through the ecosystem. We look at the different types of things, the identity access management, remote management, detection and response. All of these things are pieces that work into a zero trust model. And when you're talking about zero trust, it's not about something that you're going to get, oh, check, I'm done, everything's fine. You want to make sure that you're constantly iterating towards it. Otherwise, bad things are going to happen like this. Now, I mentioned remote desktop protocol earlier. This is a thing called Bluekeep. This is one of a host of issues that's going on right now. This is an article from last May. Right now, there is actually a worm that is going around the internet, breaking into systems that are exposed and not patched to current. This is a real problem that is happening right now. And there are tools out there for the attackers to use, such as Showdown, which is a fantastic tool. It's like Google for hackers. But the negative types can use it as well. So when I ran this quick search a while ago, it came up with 2.3 million different nodes on the internet that were exposed. This number has come down dramatically, thankfully, of late, but it still shows targets of opportunity for attackers to breach your network and then gain access to your resources, because unfortunately too many organizations don't do network zone segmentation, where they are only allowing certain zones to talk to other certain zones. I've worked in an organization that was a global footprint that had a flat network. I could sit in my office in Toronto and I could query devices in Southeast Asia and Germany. Nobody was the wiser. That's not a good way to be. Now, there are some challenges that you have to look at. You want to be able to translate the theory into applied changes. This is not always that simple. You want to make sure that you're scoping the costs, because getting senior management buy-in, no matter what the project is always an interesting adventure. You want to reverse the engineering. Try that again. Reverse engineer the current policies that you have to make sure that they are applicable. One organization I worked at, we actually did something similar where we went through and we reviewed all of the policies that we had. One of them made absolutely no sense. We had to be a certain type of accreditation in order to be compliant. And none of us could figure out what this accreditation was. And after much research, I found it, and I couldn't believe it. It was actually a swimming certification. This person actually fessed up years later. Somebody had gone through and did a copy-paste on a swimming certification and altered it slightly and put it into a policy that was then ratified for this large organization, and nobody had ever looked at it or questioned it. So you want to make sure that the policies you have to contend with are actually applicable to your environment. You want to increment things. You do not want to go all in and try to do everything at once. Zero Trust in Google's environment is a great example. That took them 7 years. And they had a concentrated team dealing with it. So there are several levels you have to look at. I'm a big fan of repetition. You want to look at user trust, establishing the users that you're dealing with in your environment. Who is allowed to access your data? Can some contractor that comes in just have access to all of your data stores? That's something to really consider. You want to go through and then look at the discovery phase. What's on your network? Are all the devices that's actually one of my coworkers, all the devices on your network, are they supposed to be there? Do you know what's on that network? And it's really interesting when you go through this exercise, you see the trusted ones, that's great, but when you find the untrusted ones, that's not so much fun. In one company I worked at, we were going through and we were doing a software rollout where we did a scan of all the nodes, and the recorded message was X number of thousands of nodes, and when we scanned it, we found there was about 40% more devices on the wire than anybody had any idea of, because nobody had been looking. You want to make sure that these devices are trustworthy. Are they in your asset inventory? Are they patched to current or N-1? Are they even supposed to be there? If you're doing BYOD, you have limited access for them, that they can only have one segment and they can only have reduced amount of resources. Things like this are what you have to take into account. Mercy me, pardon me. Enforcing adaptive policies is a really good one. You want to make sure that you are not allowing somebody in HR to be able to query a data repository. They're shouldn't be doing GitHub pulls and things to that effect. You want to make sure you have a consistent treatment across your environment so that you are making sure that you're applying the same thing to everything. In one organization I worked at, we had one senior manager who said he absolutely had to have access to all of these various sites, and he said it was for his photography project for work. And I went, all right, fine. We opened up access. And unfortunately, he then went to sites that were very much of a malicious nature, and he got himself infected with malware, which then infected our own environment, which was not much fun. So you want to make sure that you are not giving these one-offs, because this is not going to help your environment. And again, with the policies, you want to make sure that the level of hygiene in your environment is such that your data is secure, your environment is secure. You want to make sure that you have geos that are supposed to be able to access when they're supposed to. Like at one point, I was doing work for a certain military organization, and we put these bogon lists into the edge routers, and these are lists of geos that we wouldn't allow them to go to. And all of a sudden, the attack traffic dropped off precipitously. Now, this doesn't make it so that somebody from country X, Y, or Z can't get in. They just have then route through other countries, but it does make it a little bit harder for the attackers to get in. So that's one of those examples. And the application that you're dealing with, whatever it is email, whether it's Salesforce, or whatever it happens to be, you want to make sure that only your users are accessing that. So you set up a proxy that will allow them to use your multi-factor authentication to access this. Then you are specifying what resources they can get to. You can even do this for GitHub as another example. Because passwords are a broken notion. Back in 1962, MIT in Massachusetts in the United States had an incident where they had this resource which would allow students 4 hours per week to be able to do high-end computing exercises. The other students figured out that they could actually steal time from the other students by incrementing through the user IDs. So the professor's reaction was, I'm going to put a password on this. This was the first documented incident of having passwords on systems. IBM had a system that came out the same year. Even they say that MIT beat them to the punch. They were able to show that this was a reactionary measure, a point-in-time solution. And here we are in 2019, and we're still dealing with these deprecated notions. This is something that has to get better. There's even articles about it, about how multi-factor authentication is making things better in your environment. Establish trust in your users. Track the user's devices and trustworthiness. Enforce the risk-based security standards. Don't just say, because of the flaming sword of justice said, yes, you have to do this. It has to make sense. What is the risk in your environment? Are you making teddy bears or centrifuges? You got to look at it from a risk perspective. Enable secure access one application at a time. Don't try to do everything at once. That never works. Doesn't matter what it is. Now, I've rambled at you rather incessantly. These slides will be available afterwards. That being said, you can find me on Twitter or you can email me. It's also Gattaca@cisco.com works as well. And if you have any questions, I am at your mercy. Thank you.